Hi everyone, today I saw a Leetcode question called Populating next right pointer into node 2. Well, this question is very similar to the previous question called Populating next right pointer into node, but the only difference is that in this question we don't have a perfect binary tree. This means maybe some left child or the right child specific node are missing. Now let's check this example here. So in this example, I will draw a graph to help you understand. Well, we have this root node 1, so this will connect into node. Then the next level is 2 connected to 3, and 3 connected to node. Okay. And finally, we have the final level. You see the 4 connected to 5. And 5, however, you see the 3 doesn't have left child, so 5 should be connected straightly to the right child 3. Okay, so 4, 5, 7, and connect to node. Now we're done. Okay, you see the question, maybe some left child and right child some missing. And we cannot directly use the question where we check the left and right and its subtrees. So in this question, we are using the breadth search iteration solution. And let me show how it works with the coding part first, and then the graphical explanation with line-by-line coding. Okay, so our intuition is that for each level, we want to build a dummy node, and for each node in a specific level, we want to connect the dummy node to left and then left to right, and finally we visit the next node in each level. Okay, the first thing initialize, and then we check each level and which node and return. Okay, and for each level, just copy paste intuition in the coding comments to save some time. Here, dummy to left, and also left to right. Finally, visit each node. I'll finish that. Okay, for each level, we want to each next level. Okay, now finish coding comments. Let's write code it out. So the first thing to initialize current pointer root, because we are always starting the root of this binary tree. Now, while current exists, we want to check this level. So the first thing to build dummy, which is initialized at node 0. So dummy is the initial position of dummy node, and pre is updated position starting from the dummy node. And while current exists, this node is valid, I want to check the left and right child right. So if it's a left child exists, one point pre to choose its left child. So pre dot pre dot next, pre dot left, and after that we want to update the pre position. And same for the right, so just copy paste here and maybe make a slight change. Okay. Change it to the right and change it to the right. We want to finish the specific node and its child node, and want to visit next node using curl equals code to left next. By the way, with a specific level, we want to check next level. So how can we check next level? We just use curl equals dummy.next, because dummy is always the first element in a specific row. Okay. Now finally, after we check all levels, we return root and we get the binary tree. Now let's submit result works. We choose the results pass the runtime and memory usage check and quite efficient at most solutions. Okay, now finish the coding parts. Let's use the graphical explanations line by line to help you understand. Let's use example 1 here, and I will draw the graph to help you understand. So for the example 1, we have 1 here, we have 2 and 3 here, and for 2 we have 2 nodes. So we have 4, 5, right? And 3 will only have 1 node, so it's 7. So first, we are starting at current. So let me use different color. The current starting at root here, so current we're starting at here. And while current exists, well, current of course exists here is 1. I want to point a dummy node. So dummy node will study it here. So let's say it's D for dummy node. And we also study the pre at here, right? So pre, we're starting at here. Now, once built from node, we check, okay, if this node exists, well, this current node that we checked previously exists. So while this one exists, we'll check, okay, if corridor left exists, or corridor left, these two, right? So we want to point pre.next to corridor left. Pre.next equal to corridor left. And pre then is moved to pre.next. So change here to here. Okay. And after that, we also want to check the right child. So see the right child is 3. So this one do exist. So we want to point this pre.next to corridor right. So pre.next is then pointed to corridor right. And then we move the pre to corridor right. Okay, now finish this specific level. Let's check, okay, is there other nodes in this level? I think there's no other nodes, only this one. So we move to the next level. But let me clean it up. Then we can move to the next level. For next level, we are moving curl to down middle next. But you see, the previous level had down middle pointed to these two, right? So curl is actually moving to these two. So here we get new curl at 2. And let me do that again. So while curl is this, curl calls this. Then we want to set dummy node equal to pre. The dummy node here, and we want to check. Okay, here's new dummy node for next level. So just here, and the pre is also studied here, right? I want to point this one. 2 is left child, is the left child is this, but left child you see here is 4, so it's actually this. I want to point this pre to here. And after that, we updated pre to this position. Now finish the left child, let's check the right child. Well, the right child you see do exist. This is 5. Okay, it's good. And we want to point, so clean this out. Pre.next is equal to corridor right? And then we'll move pre to here. Okay, now finish this specific node, mean the subtree formed by this node. We want to move to the next position to check the next node, right? So curl is now move to this node 3. And for this node 3, we check, okay, is there left node? But 3, you see here, don't have a left child, so we just pass this to check, and we only check the right node. And right node is 7, it uses this, right? I want to pre.next to be set to corridor right, so 5 pointing to 7. And then we move pre to here, okay? And finally, we check, is there next node to this 3? There's no next node to 3, right? So we'll continue to check the next level by moving our curl to dummy.next. So this is the new curl. Let me point that out here. This is the new curl. And for this curl, we don't have the left, don't have a right. So we're moving curl to this node. And for this curl also, we don't have left and right. So we move this one to here, okay? And this one, we see this 7 also don't have left or right. So there's no need to check, and we just return the root. This the entire binary tree and I finish. Okay. Now I think my explanation will make some sense. So if you like this video, please subscribe to my channel and see you next time. Thank you.